Lesson: Challenges of Adversarial AI in Cybersecurity. Adversarial artificial intelligence presents significant challenges in the field of cybersecurity, where the stakes are incredibly high. The sophistication of adversarial AI techniques has grown rapidly, posing threats to the integrity, availability, and confidentiality of data systems. As AI technologies become more integral to cybersecurity defenses, adversaries increasingly exploit these systems using adversarial AI methods, necessitating robust defenses and innovative solutions. Understanding and addressing these challenges is crucial for cybersecurity professionals, especially those pursuing advanced certifications such as CompTIA AI Architect Plus. This lesson focuses on providing actionable insights, practical tools, and frameworks that professionals can implement to combat adversarial AI threats effectively. One of the primary challenges of adversarial AI in cybersecurity is the creation and deployment of adversarial examples. These are inputs to AI systems that are intentionally designed to cause the system to make a mistake. For instance, an attacker might subtly alter a malware sample to evade detection by an AI-based security system. The security system, trained to identify specific patterns, may fail to recognize the altered malware due to the slight modifications made by the adversarial example. This represents a significant risk, as such adversarial examples can be generated with relatively low effort and can effectively bypass sophisticated detection mechanisms. To address this, cybersecurity professionals can utilize frameworks such as the fast gradient sign method, which helps in understanding how adversarial examples are crafted and can be used to test the resilience of AI models. FGSM works by perturbing the input data in the direction of the gradient of the loss function with respect to the input, effectively finding the fastest way to mislead the model. By understanding this process, security teams can harden their models against such attacks, implementing defensive strategies like adversarial training, where the model is trained on a mixture of clean and adversarial examples to improve robustness. Another challenge posed by adversarial AI is the issue of poisoning attacks, where adversaries inject malicious data into the training datasets used by machine learning models. Poisoning attacks aim to corrupt the model's learning process, leading to erroneous outputs or behaviors. For example, a poisoning attack on a spam filter could cause it to start misclassifying spam emails as legitimate by injecting misleading examples into its training data. Detecting and mitigating poisoning attacks require careful data management and robust validation processes. One practical tool for defending against poisoning attacks is the use of differential privacy. Differential privacy introduces noise into the training data, which helps in minimizing the impact of any single data point, including any potentially malicious data. By ensuring that the influence of individual data points is limited, differential privacy can help maintain the integrity of the training process, even in the presence of adversarial data. Implementing differential privacy involves balancing the trade-off between privacy and model accuracy, which requires careful consideration and tuning. In addition to adversarial examples and poisoning attacks, the threat of model extraction attacks looms large. In these attacks, adversaries attempt to duplicate a machine learning model by querying it extensively and using the outputs to reconstruct a similar model. This can be particularly damaging when proprietary models are stolen and used illicitly. For example, an attacker might replicate a fraud detection model to understand its decision-making process, allowing them to craft fraud attempts that evade detection. To combat model extraction attacks, professionals can deploy strategies like limiting the query access to models and using techniques such as query logging and anomaly detection to identify suspicious activity. Furthermore, implementing rate limiting and introducing randomness in the model outputs can make it difficult for attackers to accurately reconstruct the model. These strategies help maintain the confidentiality of the model's architecture and parameters, providing a layer of security against unauthorized extraction. A case study illustrating the effectiveness of these defensive strategies is the deployment of adversarial training and differential privacy by leading tech companies. Google, for instance, has successfully integrated adversarial training into its AI systems to enhance their resilience against adversarial examples. By continuously updating their models with adversarially crafted data, they have significantly improved the robustness of their systems, reducing the risk of adversarial manipulation. Statistics further highlight the growing threat of adversarial AI. A study by Gartner predicted that by 2022, 30% of all AI cyber attacks will involve adversarial examples, underscoring the urgency of developing robust defenses. This statistic emphasizes the need for cybersecurity professionals to stay abreast of adversarial AI techniques and implement comprehensive strategies to safeguard their systems. Moreover, the use of AI-driven cybersecurity tools has become prevalent, offering advanced capabilities for threat detection and response. Tools like Darktrace, an AI-based cybersecurity platform, leverage machine learning to identify network anomalies and potential threats in real time. By using unsupervised learning techniques, Darktrace can detect unusual patterns that may indicate adversarial activity, providing an additional layer of defense against AI-driven attacks. In conclusion, the challenges of adversarial AI in cybersecurity are multifaceted, requiring a proactive and informed approach to defense. By understanding the nature of adversarial examples, poisoning attacks, and model extraction threats, professionals can implement practical tools and frameworks to enhance the robustness of AI systems. Techniques such as adversarial training, differential privacy, and query management play a crucial role in fortifying defenses against these sophisticated threats. As adversarial AI continues to evolve, staying informed and adopting innovative solutions will be paramount for cybersecurity professionals aiming to protect their systems and data effectively.